So the checkpoint, why HBr is active, why bromine is inactive. So in HBr you have the vibration that produces a change in dipole moment, but in Br2 there is no change in dipole moment. Now for that molecule you're given the three spectra. So here you have the IR, the MS and the NMR. So in the IR, identify the bond representing 1, 2 and 3. So first thing, even if it hasn't asked us, let's find the IHD. So oxygen is ignored, so it's C5H10. So 12 minus 10 divided by 2, so that's 1. Means there's one double bond. And if we look at the formula C5H10O2, there's O2, most probably it's a COOH. So that's the double bond here. And when you look at the IR, you see that deep and broad band. This is because of the OH in COOH. So this peak is because of the OH. These two peaks side by side, this is normally because of the CH stretching. And then you have that one broad peak, that one intense peak over here. So at around 1700 cm-1, this is because of the C double bond O stretching. In the mass spectrum, deduce the fragments. So 102, 57 and 45. Before we do this, let's try to find the MR of that molecule. So MR is 102. So that peak is the molecular peak. 45, if you still remember, 45 is associated with COOH. You can confirm this. So this is the COOH peak. Now 57, let's try to partially draw the molecule. Let's assume it's like this, because from what we have here, we know that there is a COOH, we know that there is also CH in it, and there is C double bond O, so it's confirmed. Let's try to draw it like this first. Let's try to find the MR of all these fragments. So if we add these together, we get 57. So that 57, the peak due to the 57 here might be because of CH3, CH2, CH2, CH2. So these are the different fragments responsible for these peaks. Now let's identify the peak in the HNMR. So 11.5, here there is only one peak at 11.5. So because we have confirmed that there is a COOH, so it's the hydrogen due to that COOH group. Then state what information can be obtained from the HNMR at 1.2. If we look at the HNMR at 1.2 here, we find that there is 9 proton, and all the 9 proton in the same environment, because we have only one peak. So only one peak, which means that there is only one environment, and in that one environment there is 9 protons. So from now we have to deduce the structure of X. So from X we know that it has formula C5H10O2. We have already confirmed from MS and from the IR that it contains COOH. And from the NMR, we found that there is 9 hydrogen in the same environment, which means that all the 9 hydrogen remaining, so 1 hydrogen is here, so there's 9 hydrogen remaining, they are all around the same environment. So the only way we can draw this is having CH3, CH3, CH3 around one carbon and COOH. So all these free carbons in the same environment. So this is how we use bits and pieces from IR, NMR, and mass spectrometer to confirm the structure. We went with this possible structure to having confirmed that this is actually this structure. Now we have an isomer and we need to find differences between the H and MR. So we'll proceed by first drawing the structure of that isomer. So this is an ester. So to identify the differences, we need to spot the different environments. So I have a CH3 here and a CH3 here. But if we look at these two CH3, they are found in different environments. This is bonded to a COO, CH2. This is bonded to a CH2 or C double bond O. So they are different environments. So I'm going to have free hydrogen in one environment, free hydrogen in another environment, and the CH2 here, this is in another third environment. So free environments, this is going to give me free peaks. So that's the first difference. And second difference is that here the ratio is going to be 3 is to 2. You can also add one more difference, that there is no peak at this at 11.5. This peak will not be present here.